4.1 part 2, a couple more examples. First of all, we're going to show that sine times cotangent plus 1 equals cos plus sine theta. We're going to use a two-column proof. We're going to take this side of the equation and we are going to manipulate it to the other. So the first thing I did was I distributed. I said sine times cotangent plus sine. I distributed. And then I said, well, what is sine times cotangent? And I looked, not there. Cotangent was just cos times sine. So sine times cos over sine is just cos. And that's what I did here. So I said that's just the same as cos plus sine. I made my left side into my right side, and I write at the end QED, which stands for quad erat demonstrandum, which means which was to be demonstrated. Which was to be demonstrated. I remember growing up, we used to always say quite easily done to remember it, but it really stands for which was to be demonstrated. I did what I was asked to do. Okay, now we're going to show that secant theta plus 1 over secant minus 1 plus cos plus 1 over cos minus 1 is equal to 0. So the strategy I'm going to use here is, first of all, I am going to make a common denominator. So I'm going to multiply each fraction by the opposite fraction's denominator, and it's really just multiplying by a form of 1. This cos theta minus 1 over cos theta minus 1 is just 1. So I'm not changing the value. It's like multiplying 3 by 2 over 2 and getting 6 over 2. 6 over 2 is still 3. Okay, so I multiply. I'm going to leave my bottom factored, and I'm just foiling. So secant times cos plus cos minus secant minus 1. That's all I've done. And when I do this, I notice that secant times cos, those are reciprocals. That's just 1. Secant times cos is just 1, and cos and secant is just 1. Okay? And you'll notice I have a bunch of things that cancel out. I have 1 minus 1 and 1 minus 1, that's 0. I have cos minus secant and secant minus cos. Well, cos minus cos cancels. Negative secant plus secant, that cancels. This is just 0. So I have done what I have set out to prove. So I can say QED.